Hello everyone and to Dr. Hafiza. We are from Group 4 presenting Flux Gauge Compass. These are our group members consisting of four members. Firstly, Gautam, second, myself, third, Divian, and lastly, Sophia.
So the introduction part, a flush-gate compass is a modern all-electronic compass that has no moving parts. Instead of a spinning needle, it uses coils of wire around a magnetic core to electronically sense the direction of the electric magnetic field. What is flush-gate compass? A solid-state electromagnetic device that detects the direction of the Earth magnetic field without rotating mechanical part. It serves as the primary heading sensor for most modern marine electronics. So why it matters? There are 3 points. One is powers the autopilot. It turns the magnetic direction into a digital signal needed for automatic steering. The second point stabilizes the display. It provides the heading that keeps your radar and electronic chart correctly aligned the readable. The third point act as a backup. It's a very important point. It is a reliable electronic backup heading source if the primary gyro compass fails. So there is a quote. Okay, the future of shipping is not just faster, it is a greater. So next, working principle of a flush-gate compass. A flush-gate compass operates by utilizing electromagnets coils wound around a magnetic core to detect the Earth magnetic field, and then energizing the core with an alternating current and observing the variation in the magnetic flux due to the external field. This generates a voltage in a secondary coil where the signals features such as a second harmonic indicate the strength and direction of the Earth horizontal magnetic field, enabling the electronic digitalizing measurements of heading. So in here, I attached the diagram. You can clearly see that in the flush compass divided by seven parts. One is mounting flange and universal joint, and in the above exciter coil and pickup coils and dumping fluid and sealed inner cases and sealed outer cases. For your reference, you can see through the diagram. You can see through the arrow marks where it's clearly shown. And also you can see I attached another two diagrams in near the is about the electromagnetic field directions. So next, working principle of flush-gate compass. In here I tell step by step of the flush-gate compass working principle. For the step one, excitation current. An alternating current AC is sent through the drive coil surrounding the highly permeable core. And step two, magnetic saturation we call. And this current creates a strong, rapidly oscillating magnetic field like HECC that repeatedly forces the core material into state of magnetic saturation. For the step 3, external field interactions, the Earth horizontal magnetic field like BEH superior sub okay, sub superposes itself on the oscillating field. This field is static, not oscillating. For the step 4, we call asymmetrical saturations. BEH reinforces HASC on one side of the core and opposes it on the other. This causes the core to reach and exceed the saturation asymmetrically sooner on one side and later on the other. For the step 5, induced voltage generation. And this asymmetrical change in magnetic flux is detected by the sense coil we call the Faraday's law, and including a voltage signal, often at twice the drive frequency. The final step, step 6, the signal processing and heading output. There are 2 points. One is an internal microprocessor measures the amplitude and the phase of the induced voltage. The point two, it uses this information often from two or three axes to calculate the ship's precise magnetic heading direction. That's all. Thank you.
Next, we are going to talk about the component of flux gauge compass. Firstly, magnetic core. It is made from a soft magnetic alloy with high magnetic permeability, typically pre-malloy or mu metal. These materials are easily magnetized and demagnetized. Secondly, gimbal mechanism. The sensor is suspended in a mechanical cradle cardan suspension that allows it to swing freely in pitch and roll axis. Third, drive circuit generates the AC waveform, typically a square or sine wave between 400 Hz and several kHz, to power the drive coil. Lastly, excitation coil, a coil of copper wire wound tightly directly around the ring core efficiently. Next, double gimbal is to keep flux gate array flat and permit tilt up to 30 degrees during shift, pitch, and roll. Next, primary and secondary coil. Three small coils, one primary drive coil and two secondary sense coils to detect a horizontal component of Earth's magnetic field. Moreover, soft iron frame. It accepts the flux from Earth's magnetic field each time the current is in the center coil reversed. Lastly, oil damping fluid ensures directional readings in a stable position.
Good day, everyone. So now I'm going to explain about accuracy factors. What does accuracy actually means? Static accuracy, how many degrees the reading can differ from the true magnetic heading when the ship is steady, often around plus minus 1 degree for marine flux gate units. Another one is dynamic accuracy, how well it holds that accuracy when the vessel is pitching, rolling, turning, or in rough seas. It depends on mounting, damping, and calibration. Next, we're going to talk about main technical accuracy factors. Magnetic environment. Nearby steel structure, engines, winches, and high current cables distort the Earth's field, causing deviation unless corrected, swinging the ship and storing a deviation curve. Sensor alignment. If the sensor is not perfectly aligned with the ship's fore and aft line or not level, heading can be off by several tenths of a degree. 3 axis calibration reduces this to below about zero point 0.2 minutes. Motion, pitch, and roll. Ship movement changes the angle between the sensor and the magnetic field. So, marine flux gate use gimbal or fluid mounting and sometimes rate gyro assistance to keep arrests small at heel angles up to about plus minus 35 minutes. Next, temperature, core resistance and core properties change with temperature. Good instruments use internal temperature compensation to keep drift low over the marine range, roughly negative 15 degrees Celsius to 55 degrees Celsius. As electronic filtering, damping. Digital filtering smooths the healing to avoid filter in waves. Too much filtering makes response slow. Too little makes the display jumpy, so it must be done balance stability. Hi everyone, as we talk about practical application, Central Navigation Hub. Fluxel compass serve as the primary heading reference, feeding accurate directional data to all onboard navigation and control systems for safe vessel operation. Second, system redundancy. GPS or GNSS backup ensures continuous navigation capability when satellite signals fail, while FluxGate provides independent heading reference without external dependencies. For number third, integrated decision making. Autopilot, radar, and EGDIS work in unison using FluxGate data to maintain course, track targets accurately, and update vessel position on electronic charts in real time. So number four, safety and compliance. IMO SOLAS regulations mandate functional FluxGate compass as backup navigation system. Accurate heading prevents collision risk and ensures maritime safety in all operation scenarios. So for the diagram, FluxGate compass practical applications on ship. Number one, autopilot system maintains the course automatically, receives heading data from FluxGate for continuous course keeping. For number two, radar system provides accurate bearing to target. FluxGate gives true heading reference for radar display. Third, electronic chart, also known as ECDIS, Updates ship's position on digital charts. Fluxgate heading displayed continuously on bridge. Last, GPS or GNSS backup. GPS independent navigation. Fluxgate provides heading when GPS signal is lost or unreliable. So next we're gonna talk about comparison with gyro and magnetic compass. Fluxgate compass, magnetic compass, gyro compass. These are the features. For the heading reference, fluxgate compass refers magnetic compass refers magnetic north, while gyro compass true north. And the output for fluxgate compass, digital or electronic, magnetic compass, visual, needle or card, gyro compass, digital and electronic. Power dependency requires electrical power, and for magnetic compass, independent of power, gyro compass requires electrical power. Interference for fluxgate compass, susceptible to magnetic deviation but electronically compensatable. Magnetic compass susceptible to magnetic deviation corrected via magnets or deviation card, while for gyro compass immune to magnetic interference. Stability or accuracy, excellent long-term stability, prone to short-term errors from acceleration or tilt unless compensated. For magnetic compass, poor stability in rough seas, low sensitivity, while for gyro compass, excellent short-term accuracy or stability, subject to long-term drift. Last, role in systems. For fluxgate compass, primarily electronic magnetic sensor, ideal for autopilots and integration. Magnetic compass, essential unpowered backup. Lastly, for gyro compass, primary high accuracy reference for large vessels.
For this part, I will explain the challenges and future trend of the fluxgate compass. Firstly, the limitation of the fluxgate compass. The fluxgate compass is susceptible to magnetic interference. Nearby ferrous material, electrical equipment and even cargo on board can affect its accuracy. Next, it requires frequent calibration. Deviation can change depending on the ship condition, loading and equipment placement. Another limitation is lower accuracy at high latitude. The performance of the fluxgate compass may degrade when operating near the Earth's magnetic poles. In addition, the fluxgate compass is dependent on the ship's electrical power. In the event of power failure, heading information may be lost. Lastly, it is less accurate than a gyro compass for high-speed vessels, especially during rapid maneuver. Moving on to maintenance challenges. Regular calibration and alignment are required to ensure accurate heading information. The compass must be compensated after dry docking or any major equipment change. Over time, sensor aging and drift can occur. Long-term use may reduce the sensitivity and accuracy of the fluxgate compass. The system is also vulnerable to vibration and temperature. Excessive vibration and high heat can affect the electronic component. Finally, trained personnel are required. Incorrect calibration or improper handling can result in misleading heading data, which may affect navigation safety. Next, I will discuss the future trend of modern alternative. One major development is the improvement of digital fluxgate sensor. This provides higher accuracy, better noise filtering, and reduced drift. Fluxgate compasses are also increasingly integrated with integrated bridge system or IBS. This allows seamless connection with ATIS, radar, ICE, and autopilot system. Another trend is the use of the satellite-based heading system. GNSS compasses are able to provide true heading without magnetic interference. In addition, advanced technology such as fiber optic gyro or FOG and ring laser gyro or RLG offer higher precision, no moving part and lower maintenance. Despite this advancement, fluxgate compasses remain important due to increased redundancy and are still required as backup heading sensor under SOLAS regulation. In conclusion, the fluxgate compass remains an important navigational instrument in modern maritime operation. Despite its limitations, such as susceptibility to magnetic interference and the need for regular calibration, it can still provide reliable heading information when properly maintained. With advance in digital technology and integration into integrated bridge system, the accuracy and functionality of flask compass have significantly improved. Therefore, for mariners understanding the operational limitation and maintenance requirement of the flask compass is essential to ensure safe navigation, effective use of the bridge equipment, and compliance with international maritime regulation. In summary, the flask compass continues to play a relevant role, particularly as a supporting and backup heading system in modern navigation. Thank you.